Ready to dive in. Today, we're tackling a big one: water pollution.
It's a global issue.
We've got this really detailed lesson plan to guide us, plus some powerful images that really bring the problem to life.
Visuals can be impactful.
By the end of this deep dive, you'll be able to define water pollution, pinpoint its causes, and really grasp the magnitude of its effects.
It's about connecting the dots.
Oh, and we'll definitely explore some ways we can all be part of the solution too. But first, let's set the stage. We're looking at this image of a river, or at least it should be a river.
Right.
It's just slammed with garbage. It's really disheartening. So before we get into the nitty-gritty, can you give us the scientific take on water pollution? How do experts actually define it?
It's interesting because we tend to picture trash in the water, and that's definitely part of it. But scientifically, water pollution is broader. It's the contamination of any water body, lakes, rivers, oceans, even groundwater, essentially. If there's water, it can be polluted.
Okay, so it's insidious like that. And the lesson plan really emphasizes this point about pollutants ending up in water without adequate treatment. That seems to be a huge part of the problem.
Exactly. It all comes back to this natural flow of water, how it interacts with everything around it. That's where hydrology comes in.
Right.
Hydrologists, we study those processes, the movement, distribution, quality of water, and that helps us understand how pollutants travel, how they change within those systems. And when pollutants are introduced faster than those natural processes can handle, well, that's when you get pollution. And the effects can be, well, they can snowball.
They do, and we see it firsthand in this image. Plastic bottles, an old tire. This isn't just some random occurrence, right? There's a name for this kind of pollution.
Oh, absolutely. This is a classic example of what we call point source pollution. It's pretty literal. You can point directly to where the pollution is coming from. Factories, sewage treatment plants, oil spills, any single identifiable source.
So it's the obvious culprit, so to speak. But then the lesson plan also mentions non-point source pollution. That sounds a lot stealthier. What's the difference?
Think about a big rainstorm over farmland. You can't trace the runoff to one specific pipe or ditch, right? It's coming from the entire field, picking up fertilizer, pesticides, all sorts of stuff, and washing it into rivers and streams. That's non-point source pollution. It's diffuse, harder to track down to one place. Things like agricultural runoff, urban stormwater, even atmospheric deposition fall into this category.
It's so much harder to get a handle on. And speaking of impacts, we've got this other image. This one shows a fish, but it's obviously struggling in what looks like a sea of garbage. And this is where I think some people might tune out. It's like, well, it's not my backyard, so why should we care about water pollution?
That out of sight, out of mind mentality is understandable, but it's far from out of mind for that fish in the picture. Water pollution has a devastating ripple effect on entire ecosystems. It disrupts habitats, makes it harder for species to thrive, and that leads to a loss of biodiversity, harms those intricate food chains, and can even pave the way for invasive species to muscle out the native ones.
So we're not just talking about a few pieces of trash here and there. We're talking about the health of the whole ecosystem.
Absolutely. And it goes even beyond that. Remember that image of the lake completely choked with algae?
Oh, yeah, that was pretty alarming.
That's a prime example, and unfortunately an increasingly common one, of what happens when ecosystems get out of whack. That's eutrophication, often fueled by pollution.
Okay. What causes that?
It's often about excess nutrients. Think agricultural runoff, sewage. They flow into the water, and it's like they're fertilizing an algae explosion. Now, some algae are natural, even beneficial, but too much disrupts the balance. These massive algal blooms, they block sunlight, suffocating other aquatic plants. And when those blooms die off, their decomposition sucks up all the oxygen, creating what we call dead zones. No oxygen means no fish, no life. Imagine a lake you used to swim in, now choked with algae, lifeless. That's eutrophication in action, and it's a growing problem.
Wow. Okay. So we've got this chain reaction with some potentially devastating consequences. And speaking of chain reactions, the lesson plan mentions acid rain. How does that fit into all of this?
Acid rain is a perfect example of how even the air we breathe contributes to water pollution. It starts with a chemical reaction. Fossil fuels are burned. They release sulfur dioxide and nitrogen oxides into the atmosphere.
And those are bad.
They're not great. These compounds react with water, oxygen, other substances in the atmosphere, and they transform into sulfuric and nitric acids.
And that's the acid rain. It falls back down and basically wreaks havoc.
Exactly. It falls as rain, snow, fog, even settles as dry deposition. And the result, acidification of water bodies. That can be devastating for aquatic life, especially in sensitive ecosystems. And what's even more concerning is that this pollution can originate miles away, making it even harder to control.
Okay, 2 for 2 on the depressing examples. But this last image, this one might be the most shocking. We're looking at a river, but it's bright orange. This can't be natural, can it?
You're right to be concerned. That's definitely not somewhere you'd want to take a swim. That orange color is a telltale sign of acid mine drainage. We call it AMD.
Acid mine drainage. Okay, I'm going to need a little more explanation on that one.
It's another consequence of human activities, and in this case, it's linked to mining.
Right.
Basically, when water flows over rocks that have been exposed during mining, and these rocks contain sulfur-bearing minerals, a chemical reaction takes place. And that reaction creates sulfuric acid. So you've got this acidic water, often carrying dissolved metals like iron, flowing into the surrounding environment.
And that's what creates that shocking orange color.
Exactly. That's the dissolved iron reacting with oxygen. Think of it like rusting, but on a massive scale. It's visually striking, for sure, but it's a clear sign that the water is toxic, harmful to anything living in it. And what's even scarier is that AMD can continue polluting for decades, even centuries, after the mining itself has stopped. It's a long-lasting legacy.
Okay, so that's 3 pretty heavy examples. I have to say, it's feeling a little doom and gloom right now. Is there any good news? I mean, what can we actually do about all of this?
There's always hope, and more importantly, there's always action we can take. Even small changes in our daily lives can have a big impact. It's about reducing our collective footprint on these vital water resources.
Okay, I like the sound of that. Give me some examples. What kind of actions?
Well, it starts with awareness, with taking responsibility. Simple things, like making sure our trash goes in the bin, not in the water. That makes a difference. And then there's minimizing our use of things like fertilizers and pesticides. Remember that runoff we were talking about?
Right.
Choosing organic options or even just looking at different ways to garden can significantly reduce the amount of harmful chemicals ending up in our water systems.
So, thinking about what we're putting on our lawns and our gardens, what about our cars? I feel like I'm always hearing about oil leaks and stuff like that.
You're right, that's another big one. Properly maintaining our vehicles, even small oil leaks, can contaminate a surprising amount of water. And of course, conserving water in our homes, just in our daily lives, is crucial. The less water we use, the less wastewater needs treatment, which takes some pressure off of those systems.
Makes sense. But those all feel like individual actions, you know? What about the bigger picture stuff, industries, policies, that kind of thing?
Absolutely.
Yeah.
You're hitting on a crucial point here. Systemic change is essential. We need to be supporting policies, supporting industries that are prioritizing sustainability. That means voting with our wallets, advocating for stricter environmental regulations, and getting behind companies who are making a real effort to reduce their environmental impact. Those are all ways we can drive meaningful change on a larger scale. We need to hold industries accountable and push for those innovative solutions.
This has been quite the deep dive. I'm not going to lie, it's a little overwhelming to think about. It really is. It's a lot to process. But you're right, we can't just give up. It's too easy to get bogged down in the negativity, and we definitely needed to address that. But what does the flip side look like? What does a success story look like when it comes to water pollution?
Oh, there are some incredible success stories out there.
Yeah.
Ones that offer a lot of hope and valuable lessons, too. The Cuyahoga River comes to mind.
Wait, the river that caught fire multiple times.
That's the one. It had become, well, a poster child for industrial pollution. But what's amazing is that a real concerted effort by everyday people, policymakers, and industry leaders actually led to a remarkable turnaround, the Cuyahoga River today. It's a testament to what we can achieve when we actually commit to change. It's a thriving ecosystem again, a place where people can go to enjoy nature, proof that even the most polluted waterways can be brought back from the brink.
That's incredible. It really speaks to the power of collective action, huh?
It does. And it also highlights how important that long-term commitment is, right? Cleaning up decades of pollution, it takes time, it takes resources, and it takes sustained effort. We have to stay vigilant, we have to push for ongoing monitoring, and we have to be ready to adapt our strategies as we learn more.
Okay, so we have a bit of a roadmap. We have individual actions we can take, bigger systemic changes to push for, and some really inspiring examples of what's possible. That does make me feel a bit more hopeful, honestly. Thanks for taking us on this deep dive. Eye-opening, for sure.
You bet.
I think we've all surfaced with a renewed sense of responsibility. So listeners, if this deep dive has sparked your curiosity, if you're fired up about making a difference, I encourage you to dig a little deeper into those success stories. What worked? How did they get communities involved? How did they get those industries on board? What lessons can we take away and apply to other struggling waterways around the world? Because water, it connects us all. Until next time, keep asking those questions, keep diving deeper, and keep those brains bubbling.